In this section, we're going to discuss the confidence interval around a prediction and how to get it in Excel. So creating a confidence around a prediction in multiple linear regression is a little bit different than in simple linear regression, but the formula is the same. So we can see that the formula is the predicted value, which is what we're calling y hat p, plus or minus this t alpha divided by 2 n minus k minus 1 is the critical value. And n is the number of observations, k is the number of independent variables, and then you subtract off 1 for estimating the intercept. So that's where the degrees of freedom associated with this regression are. And then this is S of p hat, or the standard error of the prediction. So it's quite easy to get the predicted value. You already know how to do that. The critical value, it's the same one that you would use in any confidence interval or hypothesis test using the t-test, the critical value approach. And then, so the difficult thing is to get the standard error around the prediction. So finding the standard error around the prediction is a little bit different than doing what we did for simple linear regression. So in simple linear regression, admittedly, it was a complicated formula, but it was something that we could compute. In multiple linear regression, it basically involves pre and post multiplying a vector by the variance covariance error matrix. And so there's not a straightforward way to do it in a class such as this one, and there's no real reason to do it. It takes a while to pre and post multiply vectors by a huge matrix, and so this is one way to get Excel to do this for us. And so what we're going to want to do is we want to create a new regression and have Excel calculate this prediction interval for us. And so we need to create new variables, and let's see how to do that. So first of all, here's our original regression results. These are housing prices. We can see that there's a whole bunch of observations. I'm actually teasing, there's only 10. And so that's not very many. We understand that. And so the dependent variable is our housing prices. The two independent variables we have are square footage, or square feet, and bedrooms. And so this is our initial or original regression results that we had run. So here's our estimated sample regression function. Housing price hat equals the intercept plus this is the coefficient estimate on square feet. This is the coefficient estimate on bedrooms. And suppose we wish to predict the price of a house with 2,000 square feet and 3 bedrooms. And so all we would do is we would put 2,000 in for square feet and 3 is the number of bedrooms, and then this is our predicted value. So the predicted value of a house with 2,000 square feet and 3 bedrooms is $293,309.71. And so now we want to put a confidence interval around this prediction to see what if we're looking at an average house. We want to see if they're statistically different from the houses that we found in this regression or not. So to do this, we have to create 2 new variables in Excel. You're going to have to create the number of new variables you're going to have to create equals the number of independent variables we have. So we have 2 independent variables. That means that we have to create 2 new variables. And so in the next slide, we're going to see how we did that. And so this is our original data set. So we can see we have 10 observations. These are our initial housing prices. These are our initial square footage. This is the initial number of bedrooms. And you can see that the values that we want to predict for fall squarely within what's happening within this regression. So we're not going outside the realm of possibilities or observations that we've seen. So we want to create 2 new variables. Our y variable, we didn't have to redo it if we didn't want to, but I just copied it over. So the y variable stays the same. Your dependent variable stays the same. And then your independent variables, all you do is take the initial independent variable and subtract off the value that you want to predict for each of your observations, in this case 10. So for example, we took 1,400, subtracted off 2,000, we ended up with 600. We took 1,600, subtracted off 2,000, we ended up with negative 400, etc. And then for number of bedrooms, you do the same thing. You take number of bedrooms, subtract off the value you want to predict for, which in this case is 3. So 3 minus 3 is 0. etc. Down to here, we have for our fourth observation, we have 4 bedrooms. We subtract off 3, we get 1. And so we get 10 new independent variables, or however many observations you have. And note that you don't have to do this each and every time. You can basically do it for your first observation and then just copy down in Excel. So we're going to run this new regression. This is the same dependent variable. We didn't have to recopy it. We could have just highlighted this one over here if we had wanted to. I think I was just showing that this is the new regression we're running. And then we have 2 new independent variables. The square feet minus 2,000 and the bedrooms minus 3. Okay, so this is a little bit messy, but these are the regression results. We can see, first of all, that the predicted value is the same predicted value that we did when we did it by hand. This is the S of p hat, the standard error of our prediction. This is for the mean prediction. And then it actually calculates this mean confidence interval for us. And so this is the mean confidence interval. To make sure that you ran this regression correctly, what you want to do is you want to see whether or not your coefficient estimates on your independent variables remain the same. So if you looked back, this 56.111, if we look back here, right there, that's the same. And then 30606, if we look, that's the same. So if these two things happen to be different in your new regression, that means you screwed up somewhere and you need to go back and figure out where and fix it. But you can see that this worked out for me. And then also the other way to check is to make sure that the predicted value is the same. So here's the predicted value, and for here, and you could check back and make sure that this was the same predicted value that I had before. So this is our 95% confidence interval for this predicted value. And so what we would say is if we did this many, many times, 95 out of 100 times, the true predicted value would fall within this interval. And so how we would use this interval is if we were a real estate agent or we were interested in buying a house with these components, we would see whether or not the house that we're interested in is statistically the same or falls within this confidence interval, or statistically different if it fell outside the interval. And again, this is for the mean prediction. On the next slide, I show how to do it for the individual prediction. And again, the difference between a mean prediction and an individual prediction is just a function of your standard error, and it's what you say you're doing. So the mean is just for the average value, individual is for one particular house in this circumstance. And so how you would do it for an individual value is that you would just add the standard error of the regression. So this is the standard error. So you would add the standard error of the prediction plus the standard error of the regression and get your new standard error. This is for the individual value. And then you calculate the confidence interval. And you can see that it's much, much wider because we're trying to get one particular thing instead of just an average value. So you can go to the housing value data set that's in Blackboard and make sure you can do this on your own before you have to do it in your homework in real life. And just one complicating factor for this is if you wanted to predict for, say, 2,500 square feet in a 4-bedroom house, then you would just have to rerun another regression. But as we always talk about, it's pretty easy to run regressions, and so it's not that big a deal. So thank you for listening to this. Hopefully it helps you learn how to do this kind of confidence interval around a prediction.